Students, this is the third chapter under Mathematical Economics, Constraint Optimization. Constraint Optimization. The process of finding maximum or minimum values is known as optimization. We are going to find the optimum values. Optimization is done with some restrictions. So it is known as constraint optimization. Minimization or maximization of the objective function is subject to the constraints. Constraints are in two types: equality constraint or inequality constraints. There are three methods to find constraint optimization. They are: first one, substitution method; second one, Lagrangian multiplier; third one, linear programming. Under this chapter, we are going to find two methods, that is substitution method and Lagrangian multiplier. Let's see the substitution method. The objective function with one constraint equality is done under substitution method. Objective function with one constraint equality. The explanatory variable is restricted to 2 in both functions. That means in the objective function and in the constraint together we have two restricted variables or two explanatory variables. Reduce the dimension by 2 steps. There are 2 steps in this substitution method. We find that under this method there are only 2 explanatory variables, one in the objective function and one in the constraint. So we are going to find the steps under substitution method. So we can reduce all the steps into 2. First we have to solve the equation for one of the decision variables and substitute this value in the objective function. These are the 2 steps under substitution method. One is solve the equation for the decision for the one of the decision variable. We have to find the value of one variable. Then this value is being substituted in the objective function. So under substitution method, the original problem, make it to an unconstrained optimization problem to finding out the values of the given variables. Unconstrained optimization problem, we are going to find the values of the given variables. Let's see the problem. For example, z is a function of x and y, where xy plus 2x is the objective function. So mark it as equation 1. Then the constraint is x plus 2y is equal to 20. Mark it as equation 2. First step is make the constraint to an unconstrained problem by finding the values of x and y. So we are going to find the values for x and y. X plus 2y is equal to 20. So we are going to find the value of x. X is equal to 20 minus 2y. So second step is we are substitute the value of x, that is x is equal to 20 minus 2y in the objective function, that is xy plus 2x. So substitute mark this as equation 3. X is equal to 20 minus 2y. We are substituting equation 3 in equation 1. So xy plus 2x is, for the place of x, we are going to write 20 minus 2y. So z is equal to 20 minus 2y. That is, you have to write in bracket. Then xy. So we have to write y plus 2x. So 2x, in the place of x, we have to substitute 20 minus 2y. Z is equal to, we have to remove, next step is remove the bracket. So multiply 20 minus 2y with y. So we will get, likewise, remove the bracket in the next part also, multiply with 2. So we will get the equation as z is equal to 20y minus 2y square plus 2 into 20, 40. 40 minus 2 into 2y, that is 4y. So the equation we can rearrange in the equation. Z is equal to 2y square minus 2y square plus 6y plus 40. Like in the quadratic equation model, we are going to rearrange the equation. So mark as equation 4. Then third step is maximization of the equation gives the optimal value of y and substitute the value in equation 3. Get the optimum value for x. The optimum values of x and y will maximize the objective function xy plus 2x subject to the constraint x plus 2y is equal to 20. So step 3 is maximization of the equation number 4. Minus 2y square plus here when we rearrange this, we will get 16y. 4y is there and 20y. 20y minus 4y, we will get 16y. So equation is z is equal to minus 2y square plus 16y plus 40. That is the equation 4. We are going to find the maximum values of x and y. So optimum values of x and y will maximize the objective function. For finding the optimum values, condition for maximization is find d by dy of z, that is equal to 0, and d square by dy square of z, that is less than 0. So it will maximize the function. D by dy of z equal to 0. Then find the second order differentiation of that, equate it to, if it is less than 0, we can find that maximization of that value. So maximization of minus 2y square plus 16y plus 40, that is d by dy of z, that is we will get minus 4y plus 16. Find the value of y minus 4y plus 16 is equal to 0. So find minus 4y plus 16. That is the differentiation. Equate into 0 and find minus 4y is equal to minus 16. So find the value of y, that is minus 16 by minus 4, that is plus 4. Okay, then dz by dy, that is equal to minus 4y plus 16. Find d square z by dy square, that is minus 4. So we get a minus 4 value here, that is less than 0, and we can find or conclude that when y is equal to 4, when y is equal to 4, the function will be maximum. So step 3, we are substituting the value of y in equation 3 to find the value of x. So x is equal to 20 minus 2y. So x is equal to 20 minus 2 into 4. The value of y is 4. So we are substituting the value of y in equation number 3. We will get 20 minus 8, that is 12. So the value of x is 12 and value of y is 4. So we can substitute the value of x and y in the objective function, that is z is equal to xy plus 2x. We substitute the value of y, that is 4, and value of x 12 in the objective function. Z is equal to 2x plus 2, z is equal to xy plus 2x. So we will get 12 into 4 plus 2 into 12, that is 48 plus 24, that is equal to 72. We can conclude that the maximum objective function maximum value is 72. So this is the substitution method under constraint optimization. Okay, thank you.